on page 219 through 222. So on to slide 3. First, angle side relationship. This is theorem 6-2 and 6-3. So that says within a triangle, the longest side is opposite the largest angle, and the shortest side is opposite the smallest angle. And here I have the diagram to show you. If I have a long side, that is going to be opposite my largest angle. If I have a short side, that is going to be opposite the smallest angle. If you think about it, if you have, my hands are merging, the smaller the angle, the shorter the side. So let's go ahead and draw this triangle, given triangle ABC, where the measure of angle A is 40 and the measure of angle B is 60. Order the lengths of AB, BC, and AC from least to greatest. So first things first, let's go ahead and let's draw the triangle. Let's see if my pen works. Nope. All right, hold on a second. Okay, and so here, it doesn't matter where you label it, we'll all get the same answer. Oh my goodness. Okay, so this will be A, B, and C. If you already drew it and drew it differently, that's totally fine. So we are told that the measure of angle A is 40 degrees. Measure of angle B is 60 degrees. And so 40 plus 60 is 100. 180 minus 100 is 80. So that would leave C being 80 degrees. So based off of what we know, my biggest angle is 80. So that means the longest side is going to be AB. All right, and then 60 is the middle angle, so opposite, so side AC is going to be my middle. Angle A is the smallest angle, so opposite the smallest angle is always the shortest side. So if we're asked to label the angles from, the side lengths from least to greatest, okay, the shortest is going to be CB, that's the shortest length. The middle length is going to be CA, and the longest length is going to be AB. Remember that when you are naming lengths of sides, order does not matter. So you could have said BC, AC, and BA. All right. Yes, Julissa?
Can we only use this with certain triangles, like only isosceles triangles, or with any triangle?
All triangles. Yep. Yeah, this is true for all triangles. Good question. All right, so let's go on to slide 4. And now I would like you to try. So this time you are going to be arranging the angles from least to greatest. So let's go ahead and see if you guys can get this one. I'll switch over. I'm going to anonymize you guys. All right, I see lots of triangles being drawn. Awesome job. That is wonderful. All right, I have 4 students who responded. I'll give you guys another minute or so. All right, 8 of you responded. I'll wait for a few more. I really like the diagrams that are being drawn. All right. Let's see, 15, 16 of you have responded, so I'll go ahead and throw up the answer. Let's go ahead and see. The correct answer is angle D, angle C, angle B. Who would like to explain how they got that as their answer? Anyone? All right, well, let's go ahead and let me look at a diagram that was done really well. Let's look at this one. All right, so we have the triangle drawn. We have the sides labeled. And so then opposite, if we're doing least to greatest, the shortest side is BC. So that means that the smallest angle is D. The middle side is DB. So opposite the middle side is C. The longest side is DC. Opposite the longest side is B. So that is why angle D, angle C, angle B. Any questions on that? All right, let's move on to slide 5. So now we're going to look at 2 triangles. So given the angle shown in the diagram, order the lengths AB, BD, CD, BC, and AC from least to greatest. So here we have 2 triangles. We are going to have to do it twice because we have 2 triangles. So I have my red triangle. And I have my blue triangle. So looking at my red triangle, the biggest angle is 80. So the longest side is BC. The middle angle is 60, so the middle side is AC. The smallest angle is 40, so the shortest side is BA. Okay. So if I am, whoops, I meant to say shortest. So if I am looking at the red triangle first, I'm going to use an inequality this time to show. So I'm doing least to greatest. So my shortest one is AB. So AB is less than, my middle is AC, and my longest is BC. Now let's do the blue triangle. So the blue triangle, the longest side, the biggest angle is 85, so the longest side is DC. That's the longest. The middle angle is 75, so the middle side is BD. And then the smallest angle, so the shortest side, is BC. So for my blue triangle, least to greatest, I have BC is less than BD, which is less than DC. Now I need to look at what the question's asking, and I need to put the two together. So it's asking from least to greatest. So do you see how they both have BC? We can go ahead and join these at BC. And I'll go ahead and draw this for you as well so you can kind of see the overlap a little bit better. So AB, AC, BC, and then it overlaps BC, BD. Oh boy, I'm going to run out of room. Is less than DC. So they have BC in common. And so the shortest, they want us to list them from least to greatest. So the shortest side is AB, then AC, then BC, then BD, then DC. I'll tell you right now, there is a question just like this on your quiz. All right, and so that is arranging them from least to greatest. Questions on that? Yes, Evie?
Could you go over why you put AB and AC first? Was it because the triangle was on the left?
No, I just did that first out of pure coincidence.
Oh.
Yeah, it doesn't matter which one you put first, but when you look to join them, you'll see that BC is the longest side for the red triangle and the shortest side for the blue triangle. So when you piece them together, you would put the red one first.
Okay, thank you.
Yep. All right, so go ahead and try 6 on your own. So I'll go ahead and get you started. What would the third angle be here? This is 61. This is 59. Remember, you have a calculator on the right. So I have 180 minus 61 minus 59. This last angle would be 60. And so this would have to be 61. All right, so go ahead and see if you guys can arrange these sides from least to greatest. All right, I like all the diagrams that I see. I like all the labeling that I see. Very good. From top of my head, I cannot remember what the answer is, so I have to look it up. All right. Famous mathematician Eva, great job. Except make sure you read the directions. It asks you to use inequality symbols. Niels, great job. ABEDC. Nina, famous mathematician, good job. Famous mathematician Bernard, awesome job. Famous mathematician Diana, great job. Famous mathematician Herman, great job. Famous mathematician Concha, good job. All right. Famous mathematician Jean, good job. All right. It looks like a lot of you got it, and that's awesome. Let me go ahead and see. Let's see. I like Bernard, how whoever Bernard is, I really like how you did this. So the left triangle, um, the shortest side was A, then B, then E. And the right triangle, the shortest side was E, then D, then C. And so when you combine them, you see that they both have E, and so you can combine them at E. Okay, sometimes you might be able to combine two of them. Two of them overlap. Sometimes they both might have the shortest side, the same shortest side. So make sure that you look at what you're being asked and look at what you have. So great job. Any questions on this one? Wonderful. Okay, great job. All right, so let's move on to slide 7. So, triangle exploration. So, now we are going to explore the relationship between the three sides of a triangle. So, go ahead, I'm going to paste your screens from slide 7 to slide 9. And so, go ahead and go through 7, 8, and 9. And we're next going to look at the sides of a triangle. So we're going to move the segments around to see if you can create a triangle with them. I'm going to be looking for participation for slide 8 and for slide 9. All right, so looking at this, great job. You all saw that, yes, you could create a triangle, and it was a scaling triangle. So looking here, you went ahead and you moved the sides, and you saw, yeah, they connect. Awesome job. All right, then looking at the next one, slide 9, you could not create a triangle with those given lengths. So if you try to create a triangle, let's see, go here. So let's see what you guys said. The distance of 10 is too big. The other two lines are short and won't touch even if they lay flat. The sides aren't long enough because the segments don't connect. Segment 10 and 4 cannot meet up because it can't be a triangle. Yep, the length of the legs was not long enough. Great job. Unable to form a triangle because sides 4 and 5 do not meet, touch at the ends. Awesome. Yep, great job, guys. Yeah, and I see you guys tried here to get them to connect, but they just won't do it. Absolutely. All right, so that brings us to slide 10. So, the triangle inequality theorem states that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So, when you add up any two sides of a triangle, it always has to be greater than the length of the third side. If you look at slide 9, if you add up 4 plus 5, that is not greater than 10. So that's why the sides did not meet. So go ahead and go on to slide 10 and see if you can determine if the sides of a triangle or if the sides can create a triangle. So remember, when you add up two sides, they always have to be greater than the third side. It says be ready to explain your answer. So go ahead and give those 3 a try. Remember, you can use the built-in calculator at the top if you need it. I'm going to be looking for 3 volunteers to either say it out loud or type into the chat for 5, 6, and 7. All right, so we can go ahead and look at the answer keys. Great job. 15 of you said that number 5, no, you cannot. That is correct. Number 6, yes, you can. That is correct. And number 7, no, you cannot. And that is correct. So looking at number 5, who would like to explain why that is no? Because not everyone got it right. Julissa?
So I tried to add up 1/4 and 2/5, and I ended up getting 0.65, and that is less than 1, so I just put no.
Very good. Yep. When you add up 1/4 and 2/5, it has to be greater than 1, and that is not true. That's false. So very good. Yep. So even if one of the combinations fail, it cannot be a triangle. So all 3 combinations, when you add up all two sides, has to be greater than the third side for every single scenario. All right, and then number 6 was yes. Who would like to tell me how they determined yes for 6? Let's see. Hold on. I see a hand up. Who is that hand? Evie.
I put yes because 2 plus 3 is 5, and that's bigger than 4. 2 plus 4 is 6, and that's bigger than 3. And 3 plus 4 is 7, which is bigger than 2.
Yep. 2 plus 5 is greater than 4. 2 plus... wait, that's not 5. 2 plus 3 is greater than 4. 2 plus 4 is greater than 3. And what's the last combination? 3 plus 4 is greater than 2. Yep, awesome. I like how you did all 3 possibilities. They all check out and work. Caleb, do you want to do the next one?
Sure.
All right.
So 10 plus 7 is 17, and then 10 plus 3 is 13, but 7 plus 3 is 10, so that would mean it's...
Very good. Yep. Yep, great job. 7 plus 3, that is not greater than 10. It equals 10. So great job, Caleb. Yes, you are correct. Okay, questions on that? So I'll tell you right now, there is a question or two like that on your quiz. So I'd say like so far this part of the lesson is just things to remember, but the content of it is not super hard. All right, let's look at another example. And this time you're going to be asked to find what is the range of the third side. So this time we are given 2 sides of a triangle. And we need to determine, well, what's the range for the third side? So it says 2 sides of a triangle have the lengths of 9 and 15. What is the range of the possible lengths of the third side? So I'll let my third side be x. So remember, based off of what we just did, when we add up 2 sides of a triangle, they always have to be greater than the third side. So that's my first scenario. Actually, let me do the math type because it's a little bit easier. So 15 plus 9 is greater than x. 15 plus x is greater than, is greater than 9. And what's the last possibility? 9 plus x is greater than 15. So now let's simplify each of these. So 15 plus 9 is 24. So 24 is greater than x. Here I'm going to subtract 15 from both sides. So x is greater than negative 6. So can I have a negative side length? No. So you can automatically reject that answer because of the negative length. Subtract 9 from both sides. X is greater than 6. So now we're going to combine those 2 inequalities and write it as 1. So here, look at the smaller number, that's 6. X has to be greater than 6. Notice how the inequality symbol is opening on the X, and less than 24. Whenever you write inequalities, you need to make sure that they are pointing in the same direction. You always start with the smaller and then go to the bigger. All right, questions on that one. So you're using exactly what we learned with the triangle inequality theorem, setting up 3 different inequalities, and then one of them is never going to work. It's going to give you something negative, so you're not going to use it. You're going to use the ones that give you positive. All right, so let's look at another example, and this time we are going to have variables. So I'm going to go ahead and draw a triangle again. And I have y plus 2, and x. Okay, the process is exactly the same. So I'm going to take y plus 2 plus y is greater than x. I'm just doing my 3 scenarios. I have x plus y is greater than y plus 2. It doesn't matter the order. You just need to make sure you hit all 3 scenarios. Then the last scenario would be y plus 2 plus x is greater than y. All right, now let's get x alone because that's my third side. So y plus y is 2y. So 2y plus 2 is greater than x. Okay, here I subtract y from both sides, so x is greater than 2. All right, here I'm going to subtract 2 and subtract y, so x is greater than 2. Any question? Wait, what did I do? I did something. Oh, sorry, it should be negative 2. Can the side length be negative? No. Yes, Julissa.
Isn't this all related to the Pythagorean theorem with the hypotenuse?
So that's a good question. We'll learn in the next unit about the 3 different possible triangles that you might have. So yes, it is related to the Pythagorean theorem in a way. And we'll get to that in a later unit. But if you're thinking that this looks kind of familiar, then yeah, you are right. All right, so since we have a negative there, that cannot be part of our answer. So let's go ahead and combine. All right, so here it says x is greater. So let me just set this up and let's decide what goes where. What's going to come on the left? I need to have the inequality opening on the x. So if you look at our middle, that would be opening on the x. Yes, Neela?
2y plus 2.
And then 2y plus 2?
Yeah.
Yes.
Wait, yeah.
Yep, because if you look here, it is not opening on the x. And look right here, it is not opening on the x. Okay, so that would be the range of the third side. Okay, all right, so that was the first part of the lesson, and now we're going to transition to the second part. There is not as much to it. I might need a lot of its vocabulary. I'll try to get to all of it in 8 minutes, but we will see. So the topic 2 is special segments. And so again, this is very heavy on vocabulary. So first, slide 14, definition of median. A median is a segment connecting a vertex. So remember, here we have the vertex to the midpoint of the opposite side. So here we have the midpoint. Remember, midpoints cut the segment into 2 congruent pieces. So all 3 of these are medians of triangle ABC. All right, so here I have the vertex, goes to the midpoint, and it cuts the third side in half, and same with this one. The midpoint theorem says every segment has exactly 1 midpoint. This allows us to add a midpoint to any segment that we want. So that is median. Altitude. An altitude of a triangle is a perpendicular segment from the vertex to the line containing the opposite side. So here's the opposite side, and it always has to be perpendicular. Altitudes can be inside the triangle, like in the first example, a part of the triangle, like in the second example, or outside the triangle. So if you see an altitude, it goes from the vertex to the opposite side and it forms a right angle. It's perpendicular. All right. Questions on median or altitude? All right. More definitions and theorems. So a perpendicular bisector, this is a definition, of a segment is a line or ray or segment that is perpendicular to a segment at its midpoint. So looking at this is my example. This right here, what I'm highlighting in blue, is my perpendicular bisector. All right, it's perpendicular and it bisects the segment. So the name of it kind of tells you exactly what it does. And then here we have perpendicular bisector theorems. So it says a point lies on a perpendicular bisector of a segment if and only if the point is equidistant from the endpoints of the segment. So what that's saying here is that if you see a scenario like this where it's the perpendicular bisector, you are going to automatically know that these sides are also congruent. All right, the reverse is also true. If you see that these two sides are congruent, then you know it is perpendicular and it bisects. Okay? And having these diagrams will help you, like in example 17 and 18. So next is angle bisector theorem. A point is on the bisector of an angle if and only if it is equidistant from the sides of an angle. So all that's saying is if you see that you have two segments and they are perpendicular to the sides of the angle, then they are going to be congruent. All right, and same thing here. If you see that these are perpendicular, you know that it bisects the angle. So let's look at example. Oh, one last thing. The distance from a point to a line, by definition, it's always the shortest distance. All right. So let's look at 17. All right. So 17, since I see that these are perpendicular, then I can also say, because of a linear pair, these are also perpendicular. So based on angle bisector theorem, if I know that these are perpendicular, that's the shortest distance, so those are congruent, and they bisect the angle. So if they are congruent, I know that those are equal. So I'm going to set up an equation to set them equal to each other. So 2x minus 7x equals 4. Think way back to unit 1. We are going to have to factor. So I'm going to subtract 4 from both sides, and we are going to factor. So as a recap for factoring, you multiply the first times the last. So a times c is -6, and b is -7. What are two numbers that multiply to give me AC? Multiply and add to give you B. If you are thinking, let's see, multiplied, oh wait, that's 8, isn't it? If you're thinking -8 and +1, you are correct. So we're going to split the middle term. Instead of saying -7x, we are going to say -8x. Let's see, multiply to give you AC, add to give you B, -8, +1. All right. Then we are going to, and I'm kind of going through this a little bit fast because I'm running out of synchronous time. So if you want to stay on afterwards, I can go over the next example with you for sure. Then I'm going to factor out my greatest common factor. You always have to factor out something. So I'm going to factor out a 1. I'm going to factor out my greatest common factor one more time, which is x minus 4. And then I have 2x plus 1 equals 0. Okay, if I am solving, I'm going to set each factor equal to 0. solve. So my answers are x equals 4, or subtract 1, divide by 2, x equals negative 1/2. If you plug in both of those, they give you a positive value, and so those are both your solutions. I know I went through that fast. I do like to respect synchronous versus asynchronous class time. So there is another factoring example, 18, that you can try if you want to stay on. I can go over it with you slower if that is something you would like. But I'm going to skip over to slide 19 and talk about what is due. So it is now asynchronous class time, and you can work on the lesson 1 quizzes assignment. And also I opened up Unit 4 test, so you can review it if you would like. All right, so that is all for today.